And this is going to be Chapter 6, Interpretation of an EKG Strip. Objectives for this are going to be describe the basic approach to interpretation of EKG strips, explain the 5 steps used in interpretation of the EKG strips, explain how to calculate heart rate given a 6-second strip, name 4 causes of artifact. General rules. The first most important, look at your patient. Read every strip from left to right, starting at the beginning of the strip. Apply the 5-step systematic approach that you will learn in this chapter. Avoid shortcuts and assumptions. A quick glance at the strip will often lead you to an incorrect interpretation. Ask the answer each question in the 5-step approach in the order that it is presented here. This is important for consistency. Master the accepted parameters for each dysrhythmia and apply them to each of the 5 steps when analyzing the strip. And the 5-step approach. This 5-step approach in order of application includes analysis of Step 1, the heart rate, Step 2, the heart rhythm, Step 3, the P wave, Step 4, the PR interval, and Step 5, the QRS complex. Whenever we're looking at EKG strips and we're doing this 5-step process, it's kind of like the electric company, and the electric company is a kid's show. The electric company had a section to it. It was a matching problem that it would throw up on the video, and it would ask you which one of these things don't belong. And if we'll just try to identify that one thing that's different from the normal, that will generally give us our answer. But it does take the 5-step approach. We need to look at all of these steps to identify that one thing that's incorrect. Step 1, the heart rate. Number of electrical impulses as represented by PQRST complexes, conducted through the myocardium in 60 seconds or 1 minute. Atrial rate, counting the number of P waves that you note, and ventricular rate, counting the number of QRS complexes that are noted. The sinoatrial node discharges impulses at a rate of 60 to 100 times per minute. Bradycardia is a heart rate less than 60 beats per minute, and tachycardia is a heart rate greater than 100 beats per minute. Heart rate determination. There are a few ways that we can do this. 2 methods of determining the heart rate is 1, the 6-second strip method, denotes a 6-second interval on the EKG strip. The strip is marked by 3 or 6-second tick marks on the top or the bottom of the graph paper. Count the number of QRS complexes occurring within the 6-second strip and then multiply that number by 10. Example of this: 1, 2, 3, 4, 5, 6, 7, 8. And we do have a P wave associated before every QRS. 1, 2, 3, 4, 5, 6, 7, 8. So the P wave rate, or the atrial rate, and the QRS rate, the ventricular rate, are the same in this, which is 80 beats per minute. The second method is the R-to-R interval method. Most accurate if the heart rate is regular. If it's irregular, then the R-to-R interval is going to change. An estimate of the actual heart rate. We'll look at the QRS complex that falls on a heavy line on the strip. Count the number of large boxes between this R wave and the next R wave. Divide this number into 300. If you remember these as well, you don't have to do any math or division. So the first, if everyone will take note, this QRS complex is very close to this line right here. So this line right here represents 300, 150, 100, 75 beats per minute. So this rhythm here is approximately 75 beats per minute. A little greater than 75 beats per minute. Step 2 is the heart rhythm. Sequential beating of the heart as a result of the generation of electrical impulses. Classified as a regular pattern. Interval between R waves are regular. An irregular pattern, interval between the R waves are not regular. Regular rhythm. Measure the intervals between P to P waves or R to R waves. If the interval varies by less than 0.06 seconds or 1.5 small boxes, we can consider the rhythm to be regular. The easiest way to do this is to take a secondary piece of paper and mark these off. So the other piece of paper would be right here along your isoelectric line. And what you would do on that piece of paper is I always generally mark off a couple of P waves and a couple of QRSs. And then what I do is I'll take that piece of paper, since it has these marks on it, and float them on the next beats so that we can see if it's consistently regular, if the P wave is consistently regular and that the QRSs are consistently regular. An irregular rhythm. If the interval between the P to P waves or the R to R waves are variable by greater than 1.5 boxes or 0.06 seconds, the rhythm is considered irregular. A regularly irregular rhythm, an irregular rhythm that occurs in a pattern. This is going to be things like atrial flutter or a heart block, to where you can see again and again and again a specific pattern, or it can even be something as small as a PAC, to where there's a premature atrial complex. But if it's coming regularly, then it would be regularly irregular. We have also something here that's considered occasionally irregular, which means the intervals of only 1 or 2 R to Rs are uneven. So this doesn't happen very often, but occasionally the rhythm is irregular. It isn't consistent. And then last but not least is the irregularly irregular. And the easy way to identify this is you cannot tell when the next R wave is going to fall. It is so irregular, it is irregularly irregular, that there's no rhyme or reason to where the next beat's going to go. There is only one rhythm that would be in this category, and this is atrial fibrillation. So a practice strip for rate and rhythm analysis. So let's do two methods on this. Let's find, first of all, this one here is one off of the major, one of the big lines, 300, 150, 100, 75, 60, 50 beats per minute. So greater than 50, less than 60. Or this is right at about 60 beats per minute. And then we can do the count and multiply by 10. This is a 6-second strip. So 1, 2, 3, 4, 5, 6. And there is a P wave associated to every QRS. So 60 beats per minute. Another practice strip here. Let's do the R to R interval first. 300, 150, 100, right at about a little less than 75 beats per minute. 1, 2, 3, 4, 5, 6, 7, 8 times 10 is 80 beats per minute, and there is a P wave associated with every QRS. So right at about 80 beats per minute on this strip. Step 3, the P waves. The P wave is produced when the right and left atria depolarize, or the initiation occurs in the sinoatrial node, and both together, the right and left atria depolarize or contract. The first deviation from the isoelectric line, it should be round and upright. The P wave is the SA node pacing or firing at regular intervals. This pattern is referred to as a sinus rhythm. So we're going to identify things that we consider to be sinus by the upright P wave that we find associated with all the QRS complexes. P wave, 5 questions to ask. Are they present? Step 1. Are the Are P waves occurring regularly? Are they actually firing off the QRSs? Step 3, is there one P wave present for each QRS complex present, or is there a QRS for each P wave that is present? Step 4, are the P waves smooth, round, upright in appearance, or are they inverted? And step 5 is, do they all look alike? A good acronym to remember is PURU. P waves that are upright, round, and uniform. PURU. And this is P wave practice here. And if we'll notice, there is a P wave that occurs before every one of the QRSs. We look down through there, and let's go ahead and get some practice at the rate. First thing we're going to do is the order interval, 300, 150, 100, about 75 beats per minute. 1, 2, 3, 4, 5, 6, 7, right at 80 beats per minute. So our RR interval and our 6-second strip method both turned out to be correct, and the P waves look uniform. Every one of these P waves, as looking at them, look like they come from about the same section of real estate in the heart. They all look round, upright, uniform, and they are present. Step 4, the PR interval. Measures the time interval from the onset of atrial contraction to the onset of ventricular contraction, measured from the onset of the P wave to the onset of the QRS. Now this is going to be from the start of the P wave to the first deflection. Normal interval is 0.12 to 0.20 seconds, or 3 to 5 small boxes. The PR interval should be no greater than 0.20 seconds total. PR 3 questions to ask. Are the PR intervals greater than 0.20 seconds? Are the PR intervals less than 0.12 seconds? Are the PR intervals consistent across the EKG strip? Now, if we have a variable rate, this could be indicative of an AV nodal block or some kind of sick sinus syndrome. A PR interval practice. So we're going to look at several of these, and we're going to measure from the start of the P wave till the first deflection here. 1, 2, 3, 4. This one here is 0.16, which is 4 small boxes. 4 times 0.04 is 0.16. And let's check another one here. We're going to start from here to the first deflection. And that is 1, 2, 3, and I got that one a little crooked. Right at about 4 small boxes, which again is 0.16 in duration. So the PR interval is correct on this. It is less than 0.20. Let's find an upright that's close to a major line, which is right there. 300, 150, 100, 75 beats per minute, greater than 75 but less than 100. And let's see that our 6-second strip method comes out correct. 1, 2, 3, 4, 5, 6, 7, 8. By 6-second strip and R-to-R method, it's right at about 80 beats per minute. We do have PURU here for step 2. The P waves are upright, they are round, and they are uniform. They all look like they're coming from about the same location. And third step, which would be PR interval, which is less than 0.20. Step 5, the QRS complexes, represents the depolarization or contraction of the ventricles. The Q wave, the first negative or downward deflection of the large complex, which is right here. The R wave is the first upright or positive deflection following the P wave, and we identify this off of the P wave. The S wave, the sharp negative or downward deflection that follows the R wave. So the S wave is going to come after the R wave, which is this one right here. So Q, R, S, P. And then the return of the S wave to the isoelectric line. The 3 questions to ask on the QRS complexes. Are the QRS intervals greater than 0.12? The QRS intervals should be no more than 3 boxes total. Are the QRS intervals less than 0.12 or narrow? Are the QRS complexes similar in appearance across the EKG strip? Well, we're going to want to know, because if there is a section of myocardium that's injured or hurt, it may give us a different waveform. Or if it's blocked in some way, it will slow down the waveform, which in our appearance of what we're looking at on the EKG paper will make the complex wider. Sample QRS rhythm strip, and we're going to do all the steps here really quick. So step 1, which is rate, and we're going to find a beat that's pretty close. This one here is pretty close, so 300, 150, 100, 75, 60, and this is right at about 60 beats per minute by guesstimation. 1, 2, 3, 4, 5, 6, and the 6-second strip method determines that as well for us. It is nice and regular. It looks like it's coming at regular intervals. Is it regular? And both the P waves are regular and the QRSs are regular. They're both coming at regular intervals. The next question we would ask is, what do my P waves look like? Are they Puru? And they are present upright, which means above the isoelectric line. They are rounded, and they are uniform. They all look like they're coming from about the same location. The next thing we would do is we would look at the PR interval. The first deflection, 1, 2, 3, 4. I got a PR interval of 0.16. So that is a normal interval, and it looks like it's keeping that throughout. And I'm going to look at the QRS width here, which is from here to here. So we have about 2 boxes, which is 0.08. So everything so far looks normal in this EKG strip. There is no aberrant findings whatsoever. The ST segment begins with the end of the QRS complex and ends with the onset of the T wave, consistent with the isoelectric line. So this right here is the ST segment. The J point, the point at which the QRS complex meets the ST segment. If the ST segment is elevated or depressed, myocardial ischemia or injury may be indicated. So the best place for us to always be able to do is to always find this J point. If we're having a hard time seeing it until our eyes get strained, the easiest thing to do is to mark a line across the entire isoelectric line and all the complexes. If we saw ST segment elevation, we would see this ST segment rising above the isoelectric line or the J point. If it's depressed, same thing. We would see a depression here below where the S wave should have returned to the isoelectric line. The T wave, produced by the ventricle's repolarization or relaxation, commonly seen in the first upward or positive deflection following the QRS. And this is the T wave. It is the repolarization of the ventricles. If we'll remember back from the previous slides, that this right here, whenever the Q wave occurs, till halfway through the T wave, this is the absolute refractory period. And anything after the T wave is halfway done to the end of it. This is the partial refractory period. Now, what we're going to see of this is if there is stimulus enough in that half section there to where the T wave has almost all repolarized, we could form something like VTAC or VFib. This is called an RONT phenomenon. The U wave, usually not visible in the EKG, cause or origin are not completely understood, typically follows the T wave and appears much smaller than the T wave, rounded, upright, or positive deflection. If they are present, they are considered a U wave. Artifact, EKG waveforms from sources outside the heart. Interference seen on a monitor or an EKG strip, and the 4 leading causes are 1. Patient movement, 2. Loose or defective electrodes, which would give you a fuzzy, wiggly baseline or isoelectric line. Improper grounding, 60 cycle interference, it's not grounded good enough, or faulty EKG apparatus. Now, the most common faulty EKG apparatus that we can see is some boogered up or banged up leads. Alright, so this is a sample rhythm of artifact, and This whole section in the middle, this squiggly line stuff, is all artifact. We can kind of make out and identify that there's a P wave in there, Q, R, S, and then a T wave. We kind of have that consistently occurring. Again and again and again. We can still get a rate on this. 1, 2, 3. It is 80 beats per minute. And that is the end of the 5-step process, or Chapter 6 of Interpretation of an EKG.